Okay, so number 82, it says light waves can be modeled by sine functions. The graphs show waves of red and blue light. Write an equation in the form y equals a sine of bx that models each of these light waves. So if you look at this first one, depending on which one we want to talk about, the red wave, focus on that a little bit. Okay, so if I look at this right here, it looks like each tick mark is going by 40. So it looks like the red wave stops at 640. It completes one period. So I'm going to go ahead and write down for the red, the period is 640, and that's nanometers. And then for the blue, it looks like it starts here and it ends right here, which looks like it ends at 480. So for blue, the period is 480. Okay, and in each of these cases, it looks like it goes up one and down one, so it looks like the amplitude A would be 1. So all I've got to do is write a function with that information. So for the red, I've got y equals 1 sine of something x, and so 2 pi divided by b equals 640, or b equals 2 pi divided by 640, which simplifies to pi over 320. So I would say pi over 320x. And there we go. Do you want to go next door? Okay. Yeah, just put it on my computer right there. And then for the blue, I'm going to have 2 pi divided by b equals 480, or 2 pi over 480 equals b. And I get that b equals pi over 240. So y equals 1 sine of pi over 240 x. And those are my answers. So really all you have to do is figure out the period. And then once you figure out period, you can find b. Alright, number, what else is the next number? 84. So 84 is graph 2 full periods of the given tangent or cotangent. Okay. Y equals negative 2 tan of pi over 4x. Okay. Graph 2 periods. Okay. So tangent is the one where you split the period across the y-axis. So if I think of this, period is pi over b, or pi over 4, which means multiply by 4 over pi, then the period is going to be just 4 of this one. So no pi involved. Okay, so what I'm going to do is I'm going to go ahead and let this be, because tangent is the one that splits on either side, I'm going to let this be 2 and let this be negative 2, which means I'm going to have a vertical asymptote here, a vertical asymptote there, and a vertical asymptote at 6. Now, if you want to go ahead and give yourself more tick marks, then you can make a tick mark at every 1 unit. And then tangent, okay, it's a negative tangent wave, so normally tangent looks like this, with vertical asymptote, vertical asymptote. So as it's negative, it's going to start from above and go down. But then it's got a 2, so that means that we're going to go, when we go left and up, we're going to go left and up 2, and right and down 2. And I'll do the same thing, repeat that there. So left and up 2, right and down 2. So my wave will look, or my 2 waves, because it said graph 2 periods, can look like this. And there we go. Okay, 85. This is a graph 2 periods again. So it's tangent of pi, x plus pi. So tangent of x plus pi. So I'm going to graph this right here. So this is kind of a weird ask because, or merely because, when I think about tangent, tangent has a period of pi, and it does this, which means that's pi over 2, and that's negative pi over 2. So right here, I don't have a period change, I don't have an amplitude change. The only thing I have is that it's going to the left pi, yeah? But the period is pi. So if I were to move this vertical asymptote right here, then that just puts it at negative pi over 2. So I had a vertical asymptote where I was going to have a vertical asymptote anyway. So if this is pi over 2, and this is negative pi over 2, and I move this vertical asymptote that was here at pi over 2 to the left pi, which is right there, then it just puts it right there. So that means at, if this was 1 pi over 2, 2 pi over 2, 3 pi over 2, if I had a vertical asymptote of 3 pi over 2, which I would have, then moving it to the left pi would have put it at pi over 2, which means by moving it, the phase shift being the period, you're not actually doing anything. You haven't moved it anywhere. So my tangent wave, midline, and then halfway between here and here, up and 1, and halfway down 1. Yes. Yes. And so then there we go there, and we've got this, and we've got that. And so there are my 2 periods of my tangent wave, shifted to the left pi. Okay. Grabbing. Okay, 88. No, that one's empty. So 88 is the next problem we got to do, and it is graph 2 periods of y equals negative 1/2 cotangent of pi over 2x. Okay. So just as a reminder, we're supposed to graph 2 periods. I could go left and right, but I'm just going to do this. Cotangent normally has a vertical asymptote at 0 and at the period, which is normally pi, and it looks like this. Okay? In this case, we have a flip, and we don't have a phase shift, so I can go ahead and lay out my vertical asymptotes. So I know that, well, I'll go ahead and plot what it is. Period is pi divided by b, pi divided by pi over 2, or multiplied by 2 over pi, and I get 2. So the period is 2, which means between 0 and 2 I should see my first cotangent wave, and between 2 and 4 I should see my second cotangent wave. So vertical asymptotes are still at 0 in the period because we don't have a phase shift. And then it's still center halfway through. But the fact that it's negative means instead of starting from above and going down, we're actually going to start from below and go up. Okay? So this is what we're going to end up looking like. We're going to start from below and go up. The question is how much do we go up and how much do we go down? So if this is 1 and this is 2 and 3, this right here at the 1/2, that means we go left and go down a half. We go right halfway and go up a half. Left and down a half. Right and up a half. So it's going to look like this. Okay? So that's how I graph 2 periods of the function in 88. Alright, 90. Graph 2 full periods of the given cosecant or secant wave. So 90 is y equals 3 secant of 2 pi x. secant is the reciprocal of cosine, so what I'm going to do is I'm going to sketch 2 full periods of my cosine wave with the same information, and then I'm going to graph the secant wave off of that. So, period is just, period for secant is the same thing as period for cosine, which is 2 pi divided by b, so 2 pi divided by 2 pi, which is 1, which means 1 period is only 1. So this down here, the 4th tick mark, I'm going to let that be 1. The 8th tick mark, I'm going to let that be 2. And I've got an amplitude of 3. So 1, 2, 3, 1, 2, 3. So I'm going to go up and down 3. Okay, so I'm going to graph a cosine wave. So cosine starts here, goes here, minimum, goes here, maximum, midline, minimum, midline, maximum. But then the goal is to graph the secant wave. So the secant wave has a vertical asymptote anytime the cosine wave hits the midline. So we've got it a 4, 3/4, 5/4, and 7/4. And then anytime secant has a max, or cosine has a max, secant has a min, and then vice versa. So my secant wave is actually this up here, and this down here. And because I know that's 2 full cosine waves, that is 2 full secant waves. Okay? Alright, number 93. 93, y equals 5/2 cosecant of x minus pi. Alright. So 1, 2, 3, 4, 5, 6, 7, 8. Graph 2 full periods. The period is going to be 2 pi divided by b, which b is 1, so the period is just 2 pi. So that means this is 2 pi and this is 4 pi. And then we want to graph amplitude lines. So up 2.5, down 2.5. What I'm going to do is I'm going to graph a regular sine wave without the phase shift. So sine wave starts and ends here, midline, max and minimum. So normally this is a sine wave. But it says the phase shift is to the right pi. Well, if 2 pi is my period, then pi is half of my period. So it's 2 tick marks. So I'm going to move this right here, and I'm going to move this right here. This right there. So this is the wave I'm going to base my cosecant wave off of. Minimum, midline, maximum, midline. So it ends up looking like a negative sine wave. Okay, so then I graph my vertical asymptotes. Anytime my sine wave hits the midline, so 0 pi, 2 pi, 3 pi, and 4 pi, and we're going to go opposite of the shifted sine wave. And there it is. Okay, so this point is 93 through 113 odd. So 93, 95. 95 is cosine inverse of 1. So don't forget that anytime you have an inverse, it's equal to an angle. So I'm finding cosine inverse of an angle, so then it's just like 1 equals cosine of what angle? Keeping in mind that cosine inverse only exists from 0 to pi, and so cosine is 1 at 0 radians. So I would say the answer is 0. 97. Sine inverse of negative square root of 3 over 2. So sine inverse equals theta. The question is negative square root of 3 over 2 is sine of what angle? And sine inverse only exists from negative pi over 2 to pi over 2. So when I look in the bottom quadrant where it's negative, if this is the point 1, 0, then this is 1, 2, 3. So sine is going to be negative square root of 3 over 2 at this angle, which is negative pi over 3. Okay. 99. Is tan inverse of negative square root of 3 over 3. Oh, that was already asked. Yeah, we already did that on number 15, so I'm just going to put number 15 on that. Okay, number 101. Sine of cosine inverse of 0. So here you're asking, this is cosine inverse that equals some angle. So you're trying to find sine of the angle. Yeah? So if cosine inverse of 0 equals some angle, that means 0 is cosine of that angle. So the question is, cosine of what angle gives me 0? And I know that from 0 to pi, this coordinate point right here, pi over 2, or this angle, is where cosine is 0, so the answer is pi over 2. So number 103, we're trying to find tangent of cosine inverse of negative square root of 3 over 2. So I know that this equals some angle, and we're trying to find tangent of the angle. Okay, so cosine inverse only exists again from 0 to pi. So as far as being negative, it's only in the second quadrant. So if this is the coordinate point negative 1, 0, then that's 1, 2, 3, 1, 2, 3. So where is cosine negative square root of 3 over 2? That is happening right here at 5 pi over 6. Okay, so we're trying to find tangent of 5 pi over 6, and tangent is sine over cosine, so that would be sine over cosine, the 1/2 divided by the negative square root of 3 over 2. I don't know if you can see that. So tangent is the y over the x, and so that's 1 over the negative square root of 3, which is negative square root of 3 over 3. I didn't find sine of that. That was ridiculous. So say, wait a minute, that's not the answer. Okay. So on this one, I found that the angle was pi over 2, and so I had to find a sine of theta equals pi over 2. So then sine of pi over 2 equals, and that is the sine value, that's 0. Gosh, no, the sine is a 1. Okay, that's embarrassing. Oh well, maybe they'll fire me. Okay, so number 103. Yeah, so we found the angle. It was 5 pi over 6, and then we were supposed to find tangent of that angle, and we got negative square root of 3 over 3. So that is the answer to 103. Number 105. So 105 is cosine of tan inverse of 3/4. Can we lock that? Yeah. Okay, so done. Okay. No, just wait until you finish the whole thing. I'm gonna step it all together. Are you continuing, or what are you continuing? Okay. No, sounds good. So, remember that this equals some angle. So, tan inverse of 3/4 equals some angle. Adarian, are you working? So tan inverse of 3/4 equals some angle, which means 3/4 is tangent of some angle. So then, if I draw a right triangle, and I let tangent be 3/4, opposite over adjacent, then the question is, what is cosine of that angle, for which tan inverse of 3/4 is the angle? Cosine of this would be, if that's a 3, that's a 4, that has to be a 5, so cosine would be 4/5. Okay. 107. Or did I say to do them all? No, I didn't. Okay. 107 is tangent of sine inverse of -3/5. So, okay. This all equals some angle, which means -3/5 is sine of some angle. So I'm going to draw that in the fourth quadrant, because that's where sine inverse exists. Is it still open? It's still unlocked? No, I lock it. Oh, you opened it. Oh, good. I was like, dang it. Okay. So, opposite over hypotenuse. And then, if this is 3, that's 4, that has to be 5. If that's 3 and that's 5, that has to be 4. And your goal is to find tangent of that angle, so tangent is opposite over adjacent, so the answer is -3/4. (109) Sine of tan inverse of -1/3. Okay, so all of this equals some angle, such that -1/3 equals tangent of that angle. Tan inverse is first and fourth, so we're going to go in the fourth quadrant, draw a triangle. Tangent is opposite over adjacent. And then I need to find the length of the hypotenuse. So I've got a squared plus b squared. 3 squared is 9. -1 squared is 1. So 9 plus 1 is 10. So this is the square root of 10. And then the question is, what is sine of that angle? So sine of the angle is opposite over hypotenuse. So -1 over the square root of 10, or -√10 over 10. And then 111. So we're supposed to find sine inverse of sine of 2 pi over 3. So in a case like this, it's tempting to cancel them out because they're sine inverse of sine, they're inverse operations, but 2 pi over 3 is outside the window for which sine inverse will equal. So what I do is I think about my unit circle, and I go to 2 pi over 3. So 2/3 is right here. And I know if this is the coordinate point 0, 1, then this is 1/2, -1/2, and square root of 3 over 2. So 2 pi over 3. So when they ask me what is sine of 2 pi over 3, sine is a y value, that's square root of 3 over 2. So I'm really finding sine inverse of square root of 3 over 2 equals what? Keep in mind that this will equal an angle. Sine inverse or in the trig inverse will always equal an angle. So it's the square root of 3 over 2 equals sine of what angle? So I have to go back to this quadrant, and I know that at pi over 3, where sine inverse exists, only from negative pi over 2 to pi over 2, the y value will be square root of 3 over 2, the sine. So my answer is at the angle pi over 3, or the whole thing equals pi over 3. And then 113, cosine of tan inverse of x over 2. So I'm going to draw a triangle for which if tan inverse of x over 2. Somebody got a question? Let me finish this problem and then I can stop the video, okay? So tan inverse of x over 2 equals theta. Then that means x over 2 equals tangent of theta. So I'm going to draw a triangle, label theta, and let tangent be opposite over adjacent. And so then the hypotenuse is a squared plus b squared equals c squared. So 4 plus x squared equals c squared, or the square root of 4 plus x squared is c. So then we're supposed to find cosine of that angle. So cosine of the angle is adjacent over hypotenuse. So that would be 2 over the square root of 4 plus x squared, which you do not need to rationalize. And so that can be your final answer. Okay, after that we're going to move into application. So I'm going to make that the last video.